A body drifts into the solar system, faint as a sigh, fragile as ash. Astronomers give it a name, 3I, Atlas, yet even that title feels temporary, like a placeholder for something already slipping away. Against the infinite tapestry of night, it appeared as a pale, thread-like ghost, glowing not with the brilliance of a star, but with the hesitant shimmer of dust, illuminated by sunlight billions of miles from home. Its trajectory marked it as an interstellar visitor, kin to the enigmatic Oumuamua and the comet Borisov, but unlike them, its presence was more evanescent, more spectral. From the beginning, it seemed to belong not to the solid cosmos of rocks and planets, but to a realm of vanishing possibilities. For a time, the world looked upward, fascinated. Scientists anticipated weeks, even months, of observation, enough to measure composition, to test models of interstellar debris, to glimpse the chemistry of another star system. Telescopes turned, data streams filled, yet what followed was not clarity, but erasure. The body dimmed faster than any prediction, collapsing not only as a physical object, but as a scientific certainty. One by one, observatories reported the same thing: absence. The coordinates yielded nothing. What had entered the solar system with the promise of revelations simply ceased to exist. And in that silence, questions multiplied. Did it disintegrate under the unrelenting breath of the sun? Was it fragile dust held together only loosely, a cosmic snowflake that melted on arrival? Or did something stranger occur, a vanishing that defied our equations, a disappearance that mocked our need for measurable continuity? The mystery deepens not because of what was seen, but because of what was lost. A world outside our world had brushed the edge of our awareness, only to retreat into non-existence. What remains is a paradox, a discovery defined by its own disappearance. In the spring of 2019, a faint glimmer on the edge of instrumental vision stirred the automated eyes of the asteroid terrestrial impact Last Alert System Atlas. The system, built to guard Earth against dangerous near-Earth objects, found instead a messenger from beyond. Its light curve was weak, its image blurred, but its speed betrayed it. This was no local wanderer bound by the sun's patient leash. This was something moving too fast, on a hyperbolic orbit that no planet could reclaim. At first, the discovery drew little noise. Objects slip into databases every week, designated, catalogued, and forgotten. Yet whispers began to spread through the astronomical community. The orbit was unbound. It would not return. This was an interstellar traveler. Such visitors are exceedingly rare, so rare that before 2017 humanity had never confirmed even one. But now, within just a handful of years, a third had arrived, and it bore the strange name 3I, Atlas, denoting it as the third known interstellar object to be recorded. Those early nights of observation were filled with anticipation. Teams from Hawaii, Chile, and Europe coordinated hurriedly, capturing photons before the ghost slipped too far into the glow of twilight or the haze of atmosphere. To astronomers, these first images were precious, evidence of a body that had wandered for untold millennia through the galactic dark, perhaps a fragment torn from another star's nursery, drifting through the void until chance brought it here. And yet even then, its fragility was apparent. The images showed a diffuse core, light leaking outward as though the object were not solid but already unraveling. Its tail was faint, inconsistent, not the proud plume of a comet, but something stuttering, indecisive, as if reluctant to declare its nature. Some wondered whether it would survive long enough to be studied at all. Still, there was wonder in those first nights. For a brief time, Earth's astronomers touched something alien. They spoke of chemistry older than the sun, of structures formed in distant molecular clouds, of interstellar debris whispering secrets. They did not yet know that what they had discovered was already vanishing, slipping toward an absence that instruments could not record. The memory of Oumuamua still lingered like an unhealed wound when 3I Atlas appeared. In 2017, that first confirmed interstellar visitor had startled the scientific world. Long, thin, and tumbling in silence, Oumuamua seemed to play tricks on every instrument that tracked it. Its brightness fluctuated erratically, its acceleration refused to fit simple models, and its shape eluded even the keenest telescopes. Some whispered it was a shard of rock stretched thin by forces unknown. Others, more daring, wondered aloud if it could be an artifact, a relic of intelligence. When 3I Atlas emerged just 2 years later, the collective imagination was primed. Here, perhaps, was a second chance, another alien fragment from the galactic sea, another opportunity to peel away mysteries hidden in the dark between stars. The comparisons were immediate. Where Oumuamua had been enigmatic and solid, Borisov, the second interstellar arrival, had been more familiar. A comet, icy and streaking with the signature gases astronomers expected. 3I Atlas seemed to fall somewhere between these two poles, part ghost, part comet, part enigma. Yet the echoes of Oumuamua's story weighed heavily. Scientists remembered the urgency, how quickly Oumuamua had passed beyond the reach of Earth's strongest telescopes, how the data had been too sparse to draw definitive conclusions. They remembered the debates that fractured the community, from careful orbital mechanics to speculative hypotheses that made front-page headlines. And so, when 3I Atlas was detected, the urgency was sharpened into something close to desperation. This time, they would not lose it. This time, they would gather enough data before the void reclaimed it. But the cosmos is indifferent to human plans. Even as observers coordinated across continents, the new visitor revealed its fragile truth. Unlike Oumuamua, which lingered long enough to spark years of arguments, 3I Atlas seemed destined for an even briefer story. Its light faded faster, its cohesion more tenuous, as if mocking the very idea of comparison. The ghostly parallel to Oumuamua served not as a guide, but as a warning. Interstellar visitors do not bend to our will. They pass through on their own terms, and they leave behind more silence than knowledge. To name a thing is to try to hold it still, to press permanence onto the fleeting. When astronomers designated the fading streak of light as 3I Atlas, they gave it a place in history, the third interstellar object ever observed. The prefix 3I marked it as the third confirmed visitor from outside the solar system. The suffix Atlas honored the survey system that had first glimpsed its fragile glow. But names, like shadows, cannot prevent disappearance. Still, the christening mattered. It was more than a code for catalogues. It was a declaration that humanity had once again brushed against the infinite. In naming, scientists acknowledged both the strangeness of its arrival and the brevity of its presence. A number and an acronym, and yet behind them lay the ancient human impulse to preserve memory, to speak against the silence of the universe. The story of interstellar naming is a story of milestones. Oumuamua, the first, was given a Hawaiian word meaning scout or messenger from afar, a name that wrapped mystery in poetry. Borisov, the second, carried the name of its discoverer, the amateur astronomer who had given the world its first true interstellar comet. And now came 3I Atlas, a name colder, more procedural, chosen not by a single observer, but by the machinery of modern survey science. Some lamented the lack of poetry, yet there was symbolism in the plainness, a reminder that the universe delivers its marvels without ceremony, and that awe is often buried beneath numbers and acronyms until human imagination breathes life into them. But the name would not hold for long. As quickly as it entered our records, 3I, Atlas began to unravel, its brightness thinning, its core refusing solidity. The designation remained, but it soon pointed to absence rather than presence, a name for something that no longer was. It became less a label for an object and more a marker for a mystery, a placeholder in the archive of cosmic questions. In this way, the very act of naming turned ironic, a title meant to preserve, now attached to vanishing. The path of 3I, Atlas, was traced in numbers, cold coordinates stitched across the sky. Within hours of its detection, orbital solutions began to pour from observatories worldwide. The verdict was unmistakable. This was no closed loop around the sun, no native comet bound by familiar gravity. Its arc was hyperbolic, too open, too swift. It had entered the solar system from the deep galactic dark and would leave it again, indifferent to the worlds it passed. Early models suggested it had threaded its way past the orbits of Mars and Jupiter with a velocity so high that no gravitational pull in our neighborhood could ever capture it. Like a stone skipped across a cosmic pond, it touched our system only briefly. Its origin lay far beyond the Oort cloud, far beyond the frozen rim of our planetary home. This was a traveler from another star, carrying with it the fingerprints of a system humanity could only imagine. Yet even in these early predictions, something unsettled astronomers. The path looked unstable, not in the sense of mechanics the equations held, but in the sense of fragility. Its projected trajectory suggested it would pass close enough to the Sun to endure intense heat and tidal stresses. Could something so tenuous survive the encounter? Orbital charts painted a story both precise and fragile, a curve bending into the solar system like an arrow, dipping close, then rising outward again. Time was short. Observations had to be made before the sun's glare swallowed the faint streak, before the object itself perhaps disintegrated. Each night of data mattered. Each photon collected a desperate attempt to turn motion into meaning. For astronomers, these trajectories were more than geometry. They were promises of chemistry, of cosmic history, of answers to questions about how other stars form their debris. But beneath the mathematics lingered a darker possibility, that the path was not just one of transit, but of erasure, a course that would end not with revelation, but with disappearance. The first attempts to read the body's light revealed not solidity, but trembling. As telescopes gathered the faint glow of 3I, Atlas, the light curve flickered, irregular and soft-edged, as if the source itself were disintegrating before human eyes. Instead of the sharp gleam of a rocky nucleus, astronomers saw the diffuse smear of dust, fragile and inconsistent. It behaved not like a comet proudly exhaling ice, nor like an asteroid stubbornly intact, but something caught between an apparition, a shell that refused to hold itself together. Spectroscopy hinted at volatile ices sublimating under sunlight, but the pattern was muted, incomplete. The glow was uneven, brightening one night, dimming the next, with no rhythm that matched rotation or outgassing jets. Observers described it as a faint signature of collapse, a comet's ghost unraveling in real time. Its coma, the cloud that should have bloomed with gases, seemed threadbare, as if sunlight passed through empty veils. In those early weeks, the numbers teased scientists with contradictions. The magnitude suggested mass, but the rapid dimming argued fragility. The distribution of dust seemed too wide for so small a core, and though fragments were suspected, telescopes could not resolve them, only diffuse streaks, as though the object's identity were dissolving into mist. To the public, these details were subtle. News outlets described it simply as a faint comet, another curiosity in the sky. But in the quiet of observatories, researchers whispered of unease. How could something traveling across interstellar gulfs arrive so delicate, that a single season's sunlight tore it apart. Was it truly a comet, or some more exotic form of interstellar debris? The faint signatures carried both promise and warning. Promise, because their strangeness might reveal conditions of distant star systems. Warning, because if the light itself faded faster than telescopes could capture, the opportunity would vanish, leaving only half-told stories etched in incomplete curves of brightness. The universe was offering a message, but in a script already fading from the page. At first, the story of 3I, Atlas, was whispered in cautious tones through NASA bulletins and short press releases. The language was dry, technical, carefully measured, as though to contain the wonder. Yet beneath the restraint lay the recognition that humanity was again brushing against something unfathomable, a visitor from beyond the solar system. The press carried echoes of this restrained excitement. Headlines spoke of a third interstellar object, often in comparison to its predecessors, Oumuamua and Borisov. Popular articles described it as a fragile comet, a shard of another star system drifting into ours. They promised the possibility of answers what ices form in alien nurseries, what chemistry endures across galactic distances. For a brief moment, the world's attention tilted skyward, drawn to a faint smudge of light moving against the stars. Yet even as the story spread, there was hesitation in NASA's voice. Unlike Borisov, which displayed the classic behavior of a comet, 3I, Atlas seemed uncertain, its behavior erratic. The public-facing words emphasized opportunity, but between the lines was an undercurrent of fragility. Short observational window, rapid evolution, further monitoring required. Phrases that suggested the scientists knew the comet might slip away before it could tell its tale. Inside observatories, the bulletins guided frantic coordination. Telescopes on mountaintops across continents adjusted schedules. Proposals were rushed through committees. Each fragment of data was relayed and archived, because every night without observation risked losing the thread forever. In this shared urgency lay the memory of Oumuamua, when hesitation had meant too little information, too much debate, and the permanent wound of unanswered questions. To the public, NASA's voice was calm, steady, almost reassuring. To the scientific community, it was a call to arms, though one delivered in the quiet grammar of orbital mechanics and brightness curves. And for those watching closely, the caution in tone hinted at what would soon become clear. The mystery of 3I, Atlas, was not one of revelation, but of disappearance. When 2I, Borisov, swept through the solar system in late 2019, it had felt like a gift to science, the first true interstellar comet, a classic spectacle with a coma, a tail, and a chemistry that could be measured. It carried the comfort of familiarity, even as it bore the thrill of alien origin. Against that memory, 3I, Atlas stood as a strange sibling, resembling Borisov at first glance, but unraveling into something more spectral, less coherent. The comparisons were inevitable. Borisov's brightness had grown predictably as it neared the sun, its gases whispering of carbon monoxide, cyanide, and other volatile ices. Instruments captured spectra that looked remarkably similar to comets born in our own Oort cloud, suggesting that across the galaxy, icy wanderers might be built from the same universal recipes. Borisov was strange only in its origin, not in its essence. But 3I, Atlas seemed to refuse that role. Where Borisov flared, this new visitor dimmed. Where Borisov presented the sturdy profile of a cometary nucleus, Atlas blurred into unresolved haze. Its tail, if it could be called such, faltered in structure, as though its material could not decide whether to cling or disperse. Observers noted its coma was thin, stretched unnaturally, almost as if sunlight were burning away its very identity. Some theorists suggested it was a fragment of a larger interstellar comet, perhaps split long before it reached our system. Others proposed that it was built of unusually fragile materials, ices mixed with dust, so loosely bound that a minor increase in solar heating would undo it. In either case, the contrast with Borisov was stark. One comet survived the sun's embrace, while the other seemed destined to vanish. The juxtaposition forced scientists to reconsider what an interstellar object truly means. If Borisov embodied resilience, a comet that mirrored our own, then 3I, Atlas embodied fragility, a transient form that crumbled before it could be studied. Together, they suggested a spectrum of wanderers, some enduring, some ephemeral, each carrying stories from distant systems but not all willing to speak. The first signs of its vanishing came quietly. Observers in early April reported that 3I, Atlas, was dimming more rapidly than any model allowed. At first, the decline was attributed to ordinary causes. Perhaps the viewing geometry had shifted, or solar radiation was scattering the coma in ways that fooled the instruments. But night after night, the pattern grew undeniable. The light curve plummeted, not with the gradual arc of a comet receding from the sun, but with the sudden fall of something breaking apart. Astronomers watched in disbelief. Predictions had suggested weeks, even months, of continued visibility. Instead, within a fraction of that time, the glow unraveled into inconsistency, like a flame sputtering in wind. By mid-spring, some instruments failed to detect it altogether. What should have been a slow fade became a collapse. The speed of the disappearance shook confidence. Comets often fragment near perihelion, torn by tides or roasted by solar heat. But 3I, Atlas, was different. Its fading began earlier, sharper, less like erosion and more like vanishing. Models of sublimation could not account for the rate. Dust production seemed inconsistent with mass estimates. The numbers did not align. For the community that had hoped to probe its chemistry, the frustration was palpable. Planned observations with large instruments, Hubble, ground-based arrays, spectroscopy runs now faced a target dissolving into nothing. Each cancellation felt like a door closing. To the public, the story was summarized in simple lines. The comet is breaking apart, but within the data lay a deeper unease. If this object was truly interstellar, forged in another star's cradle, why was it so unstable? How had it survived the gulfs of space, only to fail so quickly under our sun? Its dimming was not just a loss of light, but a rupture in expectation. 3I, Atlas, had entered with promise, carrying the weight of comparison to Borisov and Oumuamua. Now it was slipping away, erasing its own presence before instruments could decipher it. A visitor had arrived at Earth's doorstep and chosen silence instead of revelation. Then, suddenly, there was nothing more to say. NASA, which had issued cautious updates during the object's early visibility, fell quiet. Bulletins ceased. No new public observations were released. What had been a thread of reports, faint, measured, scientific, ended mid-sentence. For those who had followed closely, the silence felt louder than any explanation. Within the scientific community, the absence of updates was not unexpected. The object had dimmed beyond reliable detection, leaving little to announce. But outside that circle, speculation began to bloom. Silence invites imagination, and imagination filled the gap with suspicion. Why had NASA stopped speaking so abruptly? Was there something discovered in the fading that could not be shared? The internet carried the whispers quickly. Some argued the disappearance was too sudden, too clean, as though the object had been concealed rather than lost. Others, recalling the controversies around Oumuamua, saw conspiracy in the quiet. Perhaps 3I. Atlas had shown signatures inconsistent with natural phenomena. Perhaps its light had carried patterns mistaken for signals. In reality, the simplest truth was also the most humbling. The telescopes had nothing left to see. The object's glow had fallen below detection limits, and what remained was a sky indistinguishable from the noise of background stars. To announce absence repeatedly was to say little at all. Yet perception matters as much as fact. NASA's restraint, its unwillingness to speculate publicly, gave the impression of concealment. Each unissued bulletin became fuel for stories of alien artifacts, hidden catastrophes, or suppressed knowledge. Silence was read as secrecy. And so, in the public mind, 3I, Atlas became more than a disintegrating comet. It became a symbol of mysteries half told, of agencies that do not explain, of the uneasy line between science and imagination. A faint light in the sky had gone out, and in its place burned the brighter fire of human suspicion. The prevailing explanation among astronomers was stark in its simplicity. 3I, Atlas had disintegrated. Comets, even those born within our solar system, are fragile assemblages of ice and dust. Many do not survive their encounters with the Sunday. They fragment, scatter, and vanish into clouds of debris that fade into invisibility. For an interstellar visitor, the risks were greater still. A body forged in alien conditions, carrying materials perhaps weaker or more volatile than anything Earth's astronomers had studied. Models of disintegration soon multiplied. One suggested that as the comet approached the Sun, volatile gases trapped beneath a crust of dust erupted in sudden jets, tearing the body apart from within. Another argued that the nucleus had never been whole at all, but a loose agglomeration of grains held together by the gentlest of gravity, ready to fall apart at the first touch of heat. The accelerated dimming, the irregular light curve, the diffuse coma all pointed toward catastrophic breakup. Telescopes reported faint streaks that might have been fragments. Some images hinted at multiple sources of brightness, where once there had been one. But the evidence was tenuous, blurred by distance and faintness, and soon even those traces were gone. Nothing remained but the silence of absence. And yet, the explanation did not entirely satisfy. The timing of the breakup was early, far before the predicted perihelion. The fading was sharper, faster than most models of sublimation allowed. The supposed fragments were never clearly resolved. It was as though the comet had not merely broken but dissolved, like frost under a sudden flame. For science, disintegration was the most reasonable answer. But for imagination, the gaps in evidence were too inviting. If the comet had indeed come apart, why so quickly and why so completely? How could something that had survived eons in interstellar space crumble within days under the gaze of our sun? These questions lingered, unsettled, even as the official story hardened around the phrase catastrophic breakup. The paradox of 3I, Atlas, was this. It had traveled for millions of years through the crushing emptiness between stars, only to unravel within weeks of being seen. To astrophysicists, the fragility was astonishing. Interstellar space is no gentle cradle. Radiation, collisions with dust grains, the sheer timescales of drifting through galactic tides, all should have tested and refined its structure. Anything that survived such a journey ought to have been tough, resilient, hardened against decay. And yet, here was an object that dissolved almost instantly under the modest breath of our Sunday. Its velocity was extraordinary, nearly 30 miles per second, fast enough that no gravitational tether within the solar system could restrain it. Speed is survival in the cosmos. A body moving that swiftly should barrel through solar radiation and tidal stress with momentum to spare. Instead, its very swiftness seemed to emphasize its fragility. It was a paradox in motion, unstoppable in trajectory, yet undone in form. Some suggested that 3I, Atlas, had been weakened long before we found it. Perhaps it had endured collisions in its home system, leaving it cracked and hollow. Perhaps cosmic rays had eroded its ices until they were more void than matter. Others imagined it as a fragment, a sliver torn from a larger parent comet during some ancient catastrophe, drifting alone for eons until Earth's telescopes happened to notice its fading spark. For astronomers, the shock was not simply observational, but conceptual. Theories of cometary physics assume some degree of coherence, that a nucleus, however porous, can survive perihelion if its mass is sufficient. But 3I, Atlas defied this. It behaved as though the rules were rewritten, as though fragility itself had become its essence. This contradiction unsettled the field. If interstellar comets could be this fragile, how many others had passed unseen, dissolving before instruments could catch them? How many stories of distant systems had evaporated at the edge of detection, leaving no trace but unanswered questions? In the end, the object's speed and fragility combined into a haunting image, a traveler racing across eternity, only to collapse in the instant it brushed against human awareness. Physics depends on consistency. A comet brightens as sunlight drives sublimation. It dims as it recedes. The rate of change can be modeled, the gas and dust measured, the dynamics predicted. But 3I, Atlas refused the script. Its sudden collapse did not match the standard equations. The fade was too abrupt, the fragmentation too complete. For scientists who build trust upon reproducibility, this was unsettling. When a comet from our own Oort cloud disintegrates, there are signatures, distinct fragments traceable in images, predictable changes in light curve, dust clouds modeled with reasonable accuracy. With 3I, Atlas, those signatures blurred into contradiction. Some frames suggested multiple cores, others only haze. Its light behaved not as a sequence but as noise, a pattern that dissolved upon closer inspection. What should have been confirmation became confusion. The inadequacy of comet physics to explain the event was not merely technical. It exposed the limits of categories. Was 3I, Atlas, truly a comet at all? If it lacked the cohesion to survive, if its chemistry deviated from expectation, perhaps it represented an entirely different class of object, one never before witnessed. Some theorists hesitated even to call it a nucleus. Perhaps it was closer to an aggregate, a snowdrift of dust and ice that only masqueraded as a comet until the sun revealed its truth. For others, the unease was more philosophical. If interstellar visitors arrive carrying physics we cannot explain, how many other assumptions rest on fragile ground? The cosmos, vast and indifferent, does not bend itself to our categories. Our models are scaffolding, not certainty. And here, in the silence left by a vanishing object, that fragility was laid bare. 3I, Atlas thus became more than a disappearing light. It became a challenge, a reminder that scientific rules are not violated by the universe, only by our expectations. What crumbled in those weeks was not just an interstellar body, but the comfort that our equations could predict every visitor. As the object slipped into dissolution, telescopes caught only fragments of a story. Observatories from Chile to Hawaii reported faint streaks where once a nucleus had been. Some saw what looked like 3 or 4 discrete points of brightness, blurred by distance and faintness, dissolving into the backdrop of stars. Others recorded only a misty glow, like the afterimage of a candle extinguished. The data did not converge into clarity, it fractured into contradictions. Spectral measurements yielded little. The faintness robbed astronomers of chemical signatures they had hoped to capture. Without clean spectra, the tale of its composition remained incomplete. A few hints suggested volatile ices, perhaps carbon monoxide or cyanides, but the lines were weak, drowned in noise. The evidence came not as revelation but as whisper, fragile and uncertain. For weeks, data accumulated in fragments, a light curve here, an unresolved image there. the brief streak of dust in a long exposure. It was like trying to reconstruct a symphony from scattered notes. Each observatory reported slivers of truth, but none could assemble a whole. By the time the global network of telescopes had compared records, the object itself was gone. The archive became a mausoleum of incomplete glimpses. The frustration was sharp. Instruments had improved since Oumuamua's visit. Scientists had prepared to capture more detail, more certainty. Yet 3I, Atlas slipped away faster, leaving only partial traces. It felt as though the cosmos had mocked the readiness, dangling a mystery and then withdrawing it before clarity could form. In the end, the data resembled not a portrait, but a scattering of ashes. Nothing coherent remained, only fragments, inconsistent and insufficient, pointing toward a body that seemed to collapse not only physically, but conceptually. What the instruments recorded was less an object than the echo of its unraveling. The mystery was preserved, not solved, in those scattered fragments of data. There came a night when astronomers looked to the appointed coordinates and found only emptiness. The place in the sky where 3I, Atlas, should have been lay still, unremarkable, indistinguishable from the field of stars. Instruments swept across the sector again, recalibrated, tried different exposures, yet the silence persisted. The object had not faded slowly beyond reach. It had simply ceased, vanishing into a blind spot of the heavens. This moment was unlike the fading of a familiar comet, which arcs predictably through brightness and decline. Here, the disappearance felt abrupt, almost theatrical. One night, data points still sketched a dim curve. The next, the curve had no continuation. A presence became absence with startling clarity. The location of the blind spot compounded the mystery. The comet's projected path should have carried it toward regions still observable by major instruments. Yet the combined glare of the sun and the limitations of Earth's perspective created a wedge of inaccessibility. It was into this wedge that 3I, Atlas, slipped, a region of sky where telescopes could not follow. In the language of observation, it was a disappearance into geometry. But to those who had tracked it night after night, the blind spot felt less like geometry and more like vanishing. It resembled the edge of a stage where an actor walks off into darkness, leaving an audience in bewildered silence. The performance was over, the curtain lowered, yet the questions remained. For weeks, astronomers attempted recovery. Instruments scanned the trajectory, hunting for fragments, diffuse glows, anything that might extend the record. Each attempt returned only noise, the background static of the cosmos. It was as though 3I, Atlas, had not merely broken apart, but erased itself from visibility. In that blind spot, science collided with absence. The coordinates were known, the mathematics certain, yet the reality was void. The object that had carried the promise of revelation now lived only in calculations, not in light. It had left the universe of sight and entered the universe of memory. In the absence of direct sight, astronomers turned to models. Equations were asked to stand in for evidence, projections to serve as witnesses. Yet without the anchor of continuing observations, even the most sophisticated simulations faltered. They produced statistical phantoms, reconstructions of an object that could no longer be confirmed. Orbital mechanics predicted where fragments of 3I, Atlas, should have drifted. Dust dynamics codes simulated how grains, pushed by solar radiation, might fan into faint tails. Thermal models estimated how ice should have sublimated, how brightness should have declined. But when telescopes searched those coordinates, the sky gave back nothing. The models stood alone, uncorroborated, fragile as sketches of a vanished face. This collapse of certainty unsettled the scientific process. Data, normally the bedrock of astronomy, now consisted of scattered fragments from earlier nights. Each attempt to extend the record was a guess multiplied by a guess. One team's equations showed the body splitting into 3 distinct cores. Another's suggested it had vaporized entirely. Some models even allowed for survival of a small nucleus, drifting unseen, a ghost orbiting invisibly beyond our detection limits. In journals and conference talks, phrases like poorly constrained, uncertain and low confidence appeared again and again. The statistics did not converge. Instead of narrowing toward truth, the probability cones widened, spreading into absurdity. At the edges of those distributions, the comet's remnants could be anywhere or nowhere at all. To the public, these uncertainties were invisible. They saw only the disappearance. But for scientists, the unraveling of data into statistical ghosts was a deeper wound. The cosmos had delivered a message, and their tools could not read it. The outlines remained equations, probabilities, charts of diminishing likelihood, but they traced nothing solid. In the end, the statistical phantoms of 3I, Atlas, became metaphors as much as models, reminders that science, for all its rigor, can be left holding only shadows when reality itself refuses to stand still. Among the instruments most anticipated for the task was the Hubble Space Telescope. Its unmatched clarity had previously revealed the delicate tails of distant comets and the faint arcs of fragments tearing themselves apart. When 3I, Atlas, was announced, proposals quickly flowed to secure Hubble's gaze. Here was a chance to record an interstellar body in detail, perhaps to glimpse its pieces before they scattered into invisibility. Yet when the time came, the silence deepened. Hubble's data did not bring resolution but ambiguity. Images were faint, inconsistent, and often inconclusive. Some showed a blurred patch that might have been multiple fragments, drifting away from one another. Others revealed nothing more than diffuse haze, too faint to analyze with confidence. There was no sharp nucleus, no clear core, no survivor to study. The disappointment was heavy. Hubble had revealed crumbling comets before, capturing the delicate ballet of icy shards. But with 3I, Atlas, even that extraordinary instrument seemed blind. The absence of clarity was interpreted by many as confirmation of disintegration. If Hubble could not see a coherent body, perhaps none remained. Still, questions lingered. Why had the fragments, if they existed, dissipated so quickly? Why had no distinct cores survived long enough for follow-up? The telescope's silence became a kind of testimony, not proof of absence, but a record of vanishing. For NASA, the situation was awkward. The world expected Hubble's vision to cut through mystery. Instead, the data only widened it. Public bulletins grew fewer, their tone cautious, almost apologetic. Behind the scenes, astronomers debated whether they were watching the natural death of a fragile comet or encountering something stranger, a body whose cohesion and behavior fit no familiar category. In the great archive of Hubble's triumphs, the case of 3I, Atlas stands apart, not for what it revealed but for what it could not. Even the most powerful telescope in orbit could do little more than confirm that the sky itself had turned empty. With the object gone from sight, what remained was debate. Theorists divided into camps, each seeking to explain why 3I, Atlas, had defied expectation. To some, the answer was simple. It was a comet, fragile to its core, undone by sunlight and tidal forces. Its demise was tragic, only in timing too quick for instruments to record. Others pressed for alternative explanations. If it was merely a comet, why had it fragmented so early, far before perihelion? Why had its brightness curve fallen so sharply, unlike most disintegrations observed before? These irregularities opened the door to speculation, and speculation filled the vacuum of certainty. Some argued that it was not a singular body at all, but a loose aggregate, a cluster of icy rubble masquerading as a nucleus until sunlight exposed its weakness. Others proposed it had endured collisions in its home system that left it hollowed, cracked, more snowdrift than stone. Still others whispered about exotic origins, perhaps a fragment of a disrupted exoplanet, perhaps a sliver of material shaped under conditions alien to our chemistry. On the margins of the scientific world, wilder ideas surfaced. Was it possible the object had been artificial? Echoes of the Oumuamua debates resurfaced, recalling the suggestion of technosignatures and alien craft. Most dismissed these with caution, yet the absence of definitive data gave them space to grow. Silence is fertile soil for imagination. Conferences became arenas of quiet tension. Without new observations, every explanation stood on the same fragile ground. The camps could not resolve their differences, for the evidence had vanished along with the object itself. What remained were theories, none decisive, all incomplete. Thus 3I. Atlas joined a rare category in science, phenomena that resist closure. Its fate was not simply destruction but ambiguity, a mystery split into rival interpretations. Theorists divided, not because of arrogance, but because the cosmos had given them no more light. Among the speculative camps, one idea gained quiet traction, that 3I, Atlas, was a dark comet, a body so fragile and so thin in cohesion that it never fully behaved like the comets known within our solar system. Unlike Borisov, with its robust icy nucleus, Atlas may have been made of materials scarcely bound together, a drift of ancient dust and volatile ices compressed only lightly, more cloud than stone. In this picture, the comet's disappearance was not a surprise, but an inevitability. Such objects could wander interstellar space invisibly, carrying little mass to reflect sunlight, until a chance encounter with a star stripped them apart. They would glow only briefly, if at all, before dissolving back into the dark. A dark comet is not a contradiction but an extreme, too faint to track, too fragile to endure, too fleeting to explain. If true, the existence of such bodies had unsettling implications. They might outnumber sturdier comets, drifting unseen through galactic space. Most would never be noticed, their passage invisible to even the finest telescopes. Earth may already have been brushed by their trails countless times, without record, without awareness. 3I. Atlas could have been not an anomaly, but a glimpse of a vast hidden population. Still, the evidence remained ambiguous. No clear fragments were resolved, no spectra captured in detail. The dark comet hypothesis explained the fragility, but it did not explain the swiftness of the fade, nor the totality of the disappearance. Even in its most generous form, it left as many questions as answers. Yet the phrase carried power. Dark comet spoke to imagination, conjuring visions of fragile wanderers threading unseen paths between the stars, passing through solar systems like shadows. It offered a story to fill the silence, one that preserved the mystery while anchoring it, however loosely, to cometary science. For many, this became the working truth. 3I. Atlas was too fragile to survive, but for others, the swiftness of the collapse still whispered of forces less easily named. From the edges of cosmology came another, stranger whisper, that 3I. Atlas's vanishing hinted at physics more exotic than dust and ice. A few theorists, working in the speculative borderlands of quantum fields, wondered aloud if the object's fragility could be tied to false vacuum decay, the idea that our universe itself rests in a metastable state, balanced precariously like a ball on a plateau, vulnerable to collapse at any instant. The connection was tenuous, more metaphor than mechanism, but the imagery was irresistible. A body drifting across interstellar space, intact for eons, dissolves as if passing through an unseen membrane, a fragile bubble within the cosmic field. In this picture, 3I, Atlas became less an object and more a probe of space-time itself, an unknowing messenger revealing fault lines in the fabric of reality. Others invoked quantum fragility more literally, perhaps at scales so delicate the cohesion of interstellar rubble could be undone by quantum effects, sublimation enhanced by fluctuations, bonds weakened by radiation beyond our familiar models. The comet might have been less a nucleus and more a foam of probability, stable in the cold dark but collapsing in the presence of solar energy. Most astronomers rejected such speculations, preferring the steady ground of thermal stress and tidal forces. But the allure of exotic physics lingered. The universe, after all, is stranger than the equations we write, and when an object disappears so suddenly, so completely, it tempts us to imagine that more than dust is at work. In conferences and papers, such whispers remained footnotes, speculative asides not meant for headlines. Yet in the cultural imagination, they carried weight. 3I. Atlas became, for some, not a comet at all, but a question about reality itself. Could things unravel not just physically, but ontologically, as though the universe had erased a detail from its own page? The false vacuum did not swallow the Earth, but in the fragile vanishing of an interstellar body, humanity glimpsed how thin the line of certainty might be. Another school of thought turned not to quantum fields, but to gravitational ghosts, unseen forces tugging at 3I, Atlas, in ways that left no visible trace. Comets within our solar system often fragment when passing too near Jupiter or the Sun, torn apart by tidal stresses. Could an invisible analogue, some mass unaccounted for, have played a role in the disintegration of this interstellar body? The hypothesis arose from the strangeness of the timing. 3I, Atlas unraveled earlier than models predicted, as though an external hand had hastened its demise. Perhaps, some argued, the object had encountered a region of warped space-time, the subtle gradient of a gravitational anomaly, a phantom well not linked to any known planet or star. In such a scenario, forces could stretch and shear a fragile body into fragments too small to detect. The idea was not without precedent. Astronomers have long invoked dark perturbers to explain gaps in orbital distributions, unseen masses whose influence is inferred only from their effects. Could 3I, Atlas, have wandered into such a hidden valley, pulled apart by gravity that belonged to no visible source? Most dismissed this as unlikely. No evidence suggested a rogue planet or compact object along its path. The solar system's maps are precise, its gravitational architecture well studied, yet the allure remained. Gravity is the oldest, most relentless sculptor of the cosmos, and its invisible hand often explains what observation alone cannot. Some stretched the thought further, imagining massive bodies hidden in the interstellar dark, the very kinds of objects that surveys like Atlas and Vera Rubin Observatory are built to find. 3I, Atlas could have been a victim, an interstellar wanderer undone, not by the sun, but by the invisible relics scattered through galactic space. The notion of gravitational ghosts was never proven, but in the absence of light, it gained symbolic force, a reminder that the universe is full of unseen influences and that a vanished body might be less an accident of fragility than a clue to hidden architectures of mass. Other scientists sought explanations closer to home in the relentless breath of the Sunday. Radiation pressure, the steady push of photons, and the sublimation of buried ices could together conspire to unmake a fragile interstellar body. For ordinary comets, such processes sculpt tails and comet, shedding dust in arcs that can be predicted. But for 3I Atlas, the same processes seemed to accelerate to extremes, tearing it apart faster than anyone anticipated. Solar radiation is not uniform. Subtle fluctuations in intensity, the asymmetric heating of a rotating nucleus, or jets erupting from deep fissures, can destabilize a body already on the edge of cohesion. If 3I Atlas were composed of volatile ices, carbon monoxide, carbon dioxide that sublimate at relatively low temperatures, then its approach to the Sun may have triggered explosive outgassing. The body could have been hollowed from within, crumbling into dust clouds rather than fragmenting into solid shards. Radiation pressure compounded the effect. Once dust grains detached, sunlight pushed them outward, spreading the debris in thin, diffuse veils that quickly blended into background noise. The comet's faintness became not only a product of distance, but of dispersal, its substance smeared across the sky by the ceaseless force of solar photons. In this interpretation, nothing exotic was required. 3I Atlas simply happened to be a body of extraordinary fragility, undone by the same processes that sculpt and dissolve ordinary comets, but at a rate magnified by its constitution. The Sun did not need to act strangely, it needed only to be itself. Yet even within this explanation, unease persisted. Why had the fade been so sudden, so total? Why had no remnant nucleus survived, at least briefly, as fragments do in countless other comets? Solar breath explained the erosion, but it did not fully account for the completeness of disappearance. The Sun's warmth was sufficient cause, yet its role felt like only part of the truth. What the universe offered was a paradox, the most ordinary star performing its most ordinary act, and an interstellar visitor unraveling into mystery nonetheless. When the known forces proved insufficient, some theorists reached again for the deepest framework of all, Einstein's relativity. The equations of general relativity describe how mass bends space-time, how trajectories curve not through force but through geometry itself. Normally, these subtleties matter for planets, stars, and black holes, not fragile comets. Yet in the desperation to explain 3I Atlas, even relativity was invoked. Some suggested that small corrections from Einstein's framework, usually negligible, might have influenced the body's trajectory or internal stresses. At such high velocities, even faint relativistic effects could accumulate, magnifying fragility into collapse. Radiation pressure, gravitational tides, and relativistic perturbations together might have formed a destructive harmony. Others went further, speculating that 3I Atlas was not merely destroyed but transformed. Could interactions with the Sun's gravitational well-curved space-time itself have altered its structure in ways beyond classical physics? In most cases, relativity predicts motion with exquisite accuracy. But at the edge of understanding, where interstellar bodies meet the Sun's geometry, some dared to ask whether untested complexities might emerge. The appeal of relativity lay not only in physics but in symbolism. Einstein's theory is the great unifier, the lens through which the universe's deepest motions are seen. To tie 3I Atlas's fate to relativity was to suggest that even a fragile, crumbling comet could carry echoes of cosmic law, that its vanishing was less an accident and more a revelation of universal truth. In practice, few astronomers accepted relativity as the cause. The scales were too small, the forces too ordinary. Comets dissolve from heat, not from space-time geometry. Yet the invocation of Einstein underscored a desperation, the desire to anchor mystery in the strongest framework science possesses. Thus 3I Atlas, fading into silence, became a test not of relativity itself, but of human longing. When confronted with absence, scientists reached for the most profound of equations, hoping to find in curved space-time an echo of meaning where the data had gone dark. The disappearance of 3I Atlas inevitably revived one of the most controversial debates of modern astronomy, the alien craft hypothesis. Just 2 years earlier, Oumuamua had ignited speculation that its unusual acceleration and elongated shape might not be natural at all. Harvard astronomer Avi Loeb famously suggested it could be a fragment of extraterrestrial technology, perhaps a light sail or a derelict probe drifting between stars. Most scientists dismissed the idea, preferring icy debris over alien intent, but the notion left an indelible mark on the cultural imagination. With 3I Atlas, the parallels were too tempting to ignore. Here was another interstellar visitor, equally fleeting, equally confounding. Its premature disintegration seemed almost too neat, too clean, as if designed to prevent investigation. In the absence of fragments, some voices resurrected the possibility of artifice. What if the object had been engineered, and what we witnessed was not breakup, but departure? To be clear, the majority of astronomers rejected the idea. The behavior of 3I Atlas aligned more closely with fragile cometary physics than with technology. Its diffuse coma, its inconsistent light curve, its early dimming all pointed to natural, if unusual, fragility. No signals were detected, no repeating patterns in brightness that would hint at design. For most, the evidence did not justify the leap. Yet the alien hypothesis thrives not on data, but on absence. A body appears, stirs global attention, and then vanishes without closure. That silence feels deliberate. Human imagination fills the void with intent, because intention is easier to accept than randomness. An engineered exit explains the disappearance more cleanly than the chaos of sublimation and dust. Thus, 3I Atlas, like Oumuamua before it, became a mirror for our deepest longings and fears. The suggestion of alien design was less a theory than a story, a way to give shape to the unknown. And though science held the line with caution, the cultural imagination raced ahead, seeing in the vanished glow not a fragile comet, but a hidden message, that we are not alone, and that those who visit choose not to linger. The silence from NASA became its own kind of data. As 3I Atlas slipped from sight, the agency's communications dwindled, then ceased altogether. To scientists within the system, this was procedural, a simple matter of resources. Observatories do not chase ghosts forever. When an object fades beyond detection limits, attention shifts to the next target. But to those watching from outside, the sudden quiet felt like something more deliberate, a data embargo, a withholding. The timing sharpened suspicion. Updates had flowed regularly in the early weeks, cautious bulletins about brightness, trajectory, potential for study. Then, as the object dimmed and fractured, those reports stopped. No official statement confirmed its disappearance, no narrative explained the end. Silence replaced science, and silence is fertile soil for stories. In online forums and late-night broadcasts, speculation grew. Was NASA hiding evidence of an anomaly? Had the final images shown something inconsistent with natural behavior? Was the object, as some whispered, never a comet at all? The absence of words invited these questions, and the longer the quiet stretched, the louder the suspicions became. In truth, the explanation was prosaic. Budgets are finite, telescopes oversubscribed. A vanished body offers no more photons to capture, no more spectra to pass. For the machinery of institutional science, silence was efficiency. But institutions speak not only to scientists, they speak to publics hungry for meaning. And when meaning is withheld, it is imagined instead. Thus, the data embargo, real or perceived, became part of the story. It shifted the mystery from the sky to the agency. What had once been a cometary puzzle now seemed, to many, a human one. a question of transparency, of trust. The vanishing of 3I, Atlas blurred into a narrative of concealment, where the absence of light was mirrored by the absence of explanation. The universe had taken something away. NASA's silence made it feel as though humanity had, too. Where institutions hesitated, individual scientists stepped forward. Papers appeared in preprint archives, authored by researchers unwilling to let the mystery fade with the light. Some argued firmly for disintegration, modeling the breakup as a predictable, if unusually swift, consequence of solar heating. Others challenged that narrative, insisting the timing was too abrupt, the evidence too thin, the conclusion premature. The literature fractured into dissent. One camp emphasized fragility. They described 3I, Atlas, as a rubble pile, a cluster of loosely bound grains that unraveled at the first breath of solar radiation. Their simulations showed dust dispersing quickly into invisibility, fragments too small to track. To them, the silence of telescopes was not surprising. It was the expected end of a body never meant to endure. Another camp resisted. They pointed out that other comets, equally fragile, had left behind clear signatures of their demise, multiple nuclei, well-defined debris fields, lingering dust tails. Why had Atlas left none of these? The data, they argued, was inconclusive. To leap to disintegration was to claim certainty where none existed. Some even suggested that small surviving cores might still drift unnoticed, hidden in the glare of the sun or the noise of the sky. These disagreements were not hostile, but they revealed the discomfort of science when evidence collapses. Without continued observations, every interpretation rested on assumption. Simulations could be tuned to fit, but no simulation could resolve the absence. The papers read like echoes of a debate with no referee, models against models, all circling around a void. In conferences, the tone was similar. Presenters showed graphs of brightness, fragments of imagery, charts of probability cones, always ending with the same caveat: uncertain. The dissent was not only about 3I, Atlas itself, but about the philosophy of evidence. How does science proceed when the phenomenon itself has vanished? Thus, the object's disappearance left behind not only mystery but division. Scientists, united in method, found themselves scattered in conclusion. And in that divergence, the ghost of 3I, Atlas, lived on, not in telescopes but in argument. When professional instruments faltered, the chase was taken up by citizen astronomers. Across the world, amateurs turned their telescopes skyward, hoping to glimpse what the great observatories had lost. From suburban backyards and mountaintop cabins, they captured long exposures, combed through faint smears of light, and compared notes in online forums where excitement mingled with frustration. For a brief moment, 3I, Atlas became a shared pursuit. Images of star fields were posted and annotated, possible fragment, faint streak here, signal to noise too low. Some claimed success, pointing to dim smudges at the edge of visibility. Others dismissed these as noise, artifacts of processing, or the ghosts of cosmic rays striking sensors. Without consistency, the amateur findings dissolved into the same uncertainty that plagued the professionals. Yet the attempt mattered. Citizen telescopes, though modest, added passion to the pursuit. Their failures underscored the scale of the mystery. If, even with thousands of eyes searching, no trace remained, then perhaps there truly was nothing left to see. The emptiness confirmed itself through collective effort. The democratization of astronomy meant that for the first time, a global network of ordinary people could participate in the study of an interstellar visitor. They did not replace institutions, but they extended the narrative. The disappearance of 3I, Atlas, was no longer just a footnote in scientific papers. It was a story told in backyards and on glowing computer screens, where disappointment was shared in real time. Some amateurs clung to the possibility that NASA or major observatories knew more than they revealed. Their skepticism was sharpened by the abrupt quiet of official channels. If professionals could not explain the silence, perhaps the amateurs could. They searched not only the sky, but the gaps in communication, weaving their own hypotheses to fill the void. In the end, the citizen chase produced no proof, but it added a human layer to the mystery. The image of thousands of people scattered across the earth, staring into the same dark, trying to hold on to something that refused to stay. Patterns comfort the human mind. When faced with the mystery of 3I, Atlas, some astronomers began to ask whether its fragility was not unique, but part of a larger rhythm, a cycle of fragile interstellar wanderers passing unseen through our skies. The idea emerged from a sobering thought: we have only just begun to detect such visitors. Before 2017, none were confirmed. Since then, 3 Oumuamua, Borisov, and Atlas have been recorded within a span of only a few years. If detection is so recent, how many others must have slipped by unnoticed, especially those too faint or too fragile to endure long enough for observation? Statistical extrapolation suggested that our solar system may be brushed by interstellar bodies far more often than expected, perhaps every few years, even every few months, their appearances hidden by faintness or fleeting paths. Most would never reveal themselves. Those that did, like 3I, Atlas, might represent only a sliver of a vast unseen population. If so, its collapse was less anomaly than inevitability. Fragile aggregates may wander the galaxy in great numbers, surviving the cold dark only to crumble when warmed by a star. They could pass through countless planetary systems as ghosts, invisible except in the rare moments when geometry, timing, and technology aligned to catch their brief glow. 3I, Atlas may have been not an exception, but a glimpse into a hidden norm. The notion reframed the mystery. Instead of asking why Atlas was so fragile, scientists began to ask whether fragility itself is the rule for interstellar debris. Perhaps solid, enduring objects like Borisov are rarities, while the cosmos is littered with fragile shards dissolving on contact with starlight. For humanity, this raised both hope and humility. Hope, because future surveys might detect many more visitors. Humility, because most of them may vanish just as Atlas did, reminding us that the universe offers its secrets sparingly in flashes, in patterns glimpsed only through absence. If the story of 3I, Atlas, was one of loss, the response was one of preparation. Astronomers turned their gaze forward, toward instruments not yet fully awake. The Vera C. Rubin Observatory, with its wide-field survey power, and the James Webb Space Telescope, capable of dissecting faint spectra at exquisite detail. These tools, they hoped, would be ready for the next wanderer whenever it appeared. The Rubin Observatory, designed to scan the entire visible sky every few nights, promised a revolution. Where current surveys catch interstellar objects by chance, Rubin would make chance systematic. Its deep, sweeping images could detect fragile bodies weeks earlier than Atlas ever could. For the first time, astronomers dreamed of having not just days but months to prepare, to schedule follow-up observations before a visitor dissolved into silence. Meanwhile, Webb, already stationed in its cold, stable orbit at L2, offered the sensitivity to capture molecular fingerprints. If 3I, Atlas, had survived long enough, Webb might have resolved whether its ices carried exotic chemistry, whether its dust contained elements born in a star, unlike our Sunday. That opportunity was lost, but the telescope waits, ready for the next. Other instruments joined the anticipation: giant ground-based telescopes in Chile, radar arrays capable of imaging close passers-by, networks of small amateur scopes linked through software. The disappearance of Atlas became not just a wound, but a lesson that the universe delivers its mysteries suddenly, and science must be ready to act in kind. Even as the memory of 3I, Atlas faded into archives, proposals multiplied. Funding applications invoked its name, arguing that fragile interstellar bodies were not curiosities but a frontier. The next ghost would come. The challenge was to catch it whole before it dissolved. In this way, the loss became momentum. The cosmos had given humanity a fleeting glimpse, and in response, humanity sharpened its tools, determined that the next whisper from the galactic dark would not go unheard. What remains after the vanishing of 3I? Atlas is not data, but a philosophical wound. For science, the object is a case study in fragility. For humanity, it is a reminder of how much we do not know and how quickly knowledge can slip away. Its absence is as instructive as its presence, a comet defined not by what it revealed, but by what it withheld. We are accustomed to permanence in the heavens. Stars rise and set predictably, planets return on their circuits, even comets trace patterns that can be charted across centuries. 3I. Atlas broke that expectation. It arrived uninvited, lingered briefly, and then erased itself, leaving astronomers staring at coordinates where nothing remained. Its story is not the accumulation of data, but the erosion of certainty. This absence has a peculiar weight. It forces reflection on the fragility not only of interstellar wanderers, but of human perception itself. Our instruments, our models, our language of orbits and magnitudes, all of it depends on continuity. When continuity is denied, when a thing vanishes mid-sentence, what remains is a silence that feels almost personal. And yet, within that silence lies a kind of meaning. 3I, Atlas, reminds us that the universe is not obliged to explain itself. It offers glimpses, half-answers, shadows enough to stir wonder, but not enough to resolve it. The wound is also a gift, a push toward humility, a call to prepare better, to look deeper, to expect not only clarity, but mystery. In the end, the body that entered our system left behind no fragments, no tail, no lasting trace. What lingers instead is the memory of its vanishing, a story written in absence, a scar on the collective imagination. 3I, Atlas is gone, but the questions it raised remain, echoing in the dark. What else passes unseen? What else collapses before we notice? And how much of the universe is built not of presence, but of disappearance? To understand interstellar wanderers is to gaze into deep time. Objects like 3I, Atlas, are not born yesterday. They are fragments of stories written billions of years ago, in systems that may no longer even exist. A comet drifting into our solar system could be older than Earth itself, forged in the circumstellar disk of a long-dead star, cast out by gravitational encounters and left to wander the galactic dark for eons. When astronomers study such bodies, they are not merely studying ice and dust, they are touching the archaeology of stars. Each grain within 3I, Atlas, may have carried isotopic ratios, unlike those found in our system, fingerprints of alien chemistry. Its ices may have condensed under pressures and temperatures our sun never knew. In this sense, the object was not just a visitor, but a messenger, a shard of time, so ancient it blurred the line between science and myth. Oumuamua, Borisov, and now Atlas, each has offered a different glimpse into this deep time. One stretched thin and enigmatic, another robust and cometary, and Atlas fragile, ephemeral, like a snowflake dissolving on contact with warmth. Together, they sketch a spectrum of possibility, reminders that the galaxy is full of materials shaped by histories we cannot witness directly. What makes 3I, Atlas, most haunting is that its message was almost delivered. Had it survived a few weeks longer, spectra could have revealed the chemistry of another system's nursery. Isotopic analysis could have confirmed whether comets are universal or whether each star sculpts its fragments uniquely. Instead, the data slipped away, leaving us with questions suspended in the void. In deep time, loss is normal. Stars are born and extinguished, planets form and crumble, civilizations rise and fade. 3i. Atlas was a fragment of that immense rhythm. Its vanishing reminds us that time itself is the true author of mystery, and that humanity's glimpse of galactic history is always fleeting. Astronomers sometimes describe the detection of an interstellar object as a cosmic lottery. The galaxy is vast, and its wanderers are countless, but the odds of one passing close enough to Earth to be noticed are infinitesimal. Our telescopes sweep only narrow windows of sky, their fields of vision dwarfed by the immensity of space. To catch a body like 3i, Atlas is not inevitability, but fortune, the alignment of chance, geometry, and timing. And yet, in just a few years, humanity had drawn the winning ticket 3 times: Oumuamua in 2017, Borisov in 2019, and Atlas in 2020. The sudden clustering unsettled expectations. Were we simply lucky, or had interstellar objects been brushing past us all along, invisible until our instruments grew sharp enough to notice? If so, the lottery may not be rare at all, but a constant game in which humanity has only just learned to play. The odds also underscore the fragility of knowledge. To glimpse such an object requires not only chance, but readiness. Had Atlas arrived a decade earlier, it would have passed unseen, a ghost unrecorded. Even now, with modern surveys, it barely revealed itself before dissolving into silence. The lottery was won, but the prize was ash. This sense of improbability heightens the mystery. That Earth, orbiting one ordinary star, should witness fragments from distant suns at all is astonishing. Each detection feels less like routine astronomy and more like an encounter with destiny, as though the universe occasionally lowers its veil to remind us of its vastness. But the lottery metaphor carries a darker weight. Not all winnings are kept. 3i. Atlas was drawn from the galactic urn, shown briefly, then snatched away. What remains is the paradox of extraordinary odds, yielding only absence. Humanity held a ticket to deep time, and when the number was called, the prize dissolved before it could be claimed. Before the light was lost entirely, astronomers strained to read what little they could of 3i, Atlas's molecular traces. Spectrographs, tuned to split faint photons into their constituent colors, sought the chemical fingerprints of gases escaping its fragile core. Even blurred and weak, the spectra hinted at a familiar yet alien chemistry. Preliminary analyses suggested the presence of cyanide, carbon monoxide, and possibly fragments of water vapor, the volatile ices common to many comets. But the signals were faint, ambiguous, buried in noise. Each dataset carried caveats: low signal-to-noise ratios, uncertain baselines, incomplete calibrations. Scientists debated whether the supposed peaks were real or artifacts of instrumentation. Still, the idea was tantalizing. If real, these molecules would suggest that comets, no matter their stellar birthplace, may share a universal chemistry, that across the galaxy, icy bodies carry the same primordial ingredients. In this view, 3i, Atlas, was a thread connecting our solar system to others, evidence that the seeds of water and organics are not local accidents, but galactic norms. Yet the evidence refused solidity. Unlike Borisov, whose chemistry was confirmed with confidence, Atlas left only hints. Its coma was too faint, its disintegration too swift. By the time instruments like Hubble and the Very Large Telescope could be coordinated, The object's glow had already thinned beyond analysis. What remained were fragments of spectra, each open to interpretation, none decisive. Some speculated that the apparent abundance of carbon monoxide, if genuine, might explain the fragility. Such volatile ices sublimate at lower temperatures, destabilizing a nucleus before perihelion. Others argued the cyanide peak was noise, a phantom conjured by faint data. The debate itself became a mirror of the object's nature, unstable, dissolving, difficult to hold. Thus, the molecular traces of 3I, Atlas, became less a discovery than a promise unfulfilled. The chemistry of a distant star system may have brushed against our detectors or may have slipped past unseen. In the end, the spectra carried the same paradox as the comet itself. A story begun but never finished. In the weeks following its discovery, theorists began sketching visions of 3I, Atlas's inner structure. The favored picture was grim, a collapsing core, brittle and hollow, more void than substance. Unlike Borisov, which held together through its solar passage, Atlas seemed to betray weakness from the start. Its light curve fluctuated too erratically, its coma too diffuse, as though the body had no coherent heart. Some proposed it was a fragment of a larger interstellar comet, split long ago by gravitational tides in its home system. If so, its interior might have been riddled with fissures, honeycombed with cavities where volatiles hid in fragile balance. When sunlight reached those spaces, pressure would build until the walls collapsed, shattering the object from within. Others suggested that cosmic rays had hollowed it during its endless drift. For millions of years, radiation could have eroded ices into pockets, leaving behind a latticework structure barely able to endure. A body like that might survive the cold dark, where stresses are minimal, but would unravel at the first brush of stellar heat. The collapse was not only structural but symbolic. Humanity had hoped for a coherent messenger, a solid sample of another star's chemistry. Instead, it was given something that crumbled at the threshold of study. A hollow traveler, undone by its own fragility, dissolving into dust before secrets could be retrieved. The image of a collapsing core became a metaphor that reached beyond astronomy. It suggested the fragility of assumptions, the danger of expecting permanence in a universe built on impermanence. If even interstellar messengers arrive hollow, what confidence can we hold in the solidity of our own categories? Thus, 3I, Atlas's core collapsed not only in space but in thought. It left behind no nucleus to measure, no fragments to follow, only the haunting suggestion that what we imagine as solid may, under the universe's gaze, prove empty within. Numbers are supposed to bring order. Orbital mechanics, brightness curves, sublimation rates, all are meant to translate the sky into certainty. But with 3I, Atlas, the numbers no longer fit. The models diverged, the predictions failed, and the data refused to align with the equations. Brightness decay, for example, should follow a curve predictable from solar heating and dust dispersal. Instead, Atlas dimmed far faster than expected, its decline steeper than any formula could explain. Calculations of mass suggested a nucleus too large to vanish so quickly, while the observed light implied something far smaller. The contradictions piled like mismatched fragments of a puzzle. Even the trajectory, once precisely charted, began to feel unstable in the absence of confirmation. With the comet gone from sight, orbital models became extrapolations, not verifications. Probabilities widened. The elegant arc plotted across the solar system turned into a fan of uncertainty, a geometry that stretched toward absurd possibilities. This breakdown unsettled astronomers. Comets are chaotic, but they are not unknowable. Equations of sublimation, radiation pressure, and gravitational tides usually hold, even when fragments scatter. Yet Atlas resisted quantification. Every input seemed to collapse into noise. The numbers produced phantoms, but not clarity. For some, the failure was humbling. Science thrives on anomalies, but it also depends on closure. Here was a body that refused closure, reducing mathematics to speculation. The equations did not fail because they were wrong, but because reality withheld the data needed to complete them. The cosmos had offered only half a problem, then withdrawn the rest. In the end, the failure of numbers mirrored the collapse of the comet itself. Both dissolved under scrutiny, one into dust, the other into paradox. The mystery of 3I, Atlas, was not only what it was, but how it forced the strongest tools of human understanding to stumble, leaving only broken sums in its wake. If 3I, Atlas, left no nucleus, perhaps it left a geometry of breakup. Astronomers turned to simulations, trying to reconstruct how fragments might have scattered once the body gave way. In these models, a nucleus split into shards that drifted apart, pulled by solar tides, pushed by radiation pressure, smeared into streams too faint to trace. The geometry mattered. When other comets disintegrate, their debris often follows predictable arcs, leaving trails or fans that telescopes can recover. For Atlas, the models suggested fragments dispersing so widely and so quickly that detection would have been nearly impossible. Small shards could have been carried hundreds of thousands of kilometers apart in days, their brightness falling below limits before instruments could find them. Some imagined a catastrophic breakup triggered by asymmetric outgassing, where jets of sublimating gas launched fragments outward in random directions. Others pictured a nucleus collapsing inward, collapsing into rubble that spread like smoke in the wind. In both cases, the aftermath would not resemble the orderly dance of cometary fragments, but chaos, a geometry that dissipated into invisibility. This possibility explained why telescopes recorded only haze, never distinct survivors. It was not that fragments failed to form, but that they scattered into patterns too diffuse to resolve. What remained was a statistical geometry, drawn not in light but in probability. And yet, even this reconstruction felt incomplete. The geometry of debris should have left traces, faint dust tails, asymmetries in brightness, streaks across long exposures. Some were reported, but never consistently. Once again, the evidence dissolved at the threshold of certainty. In this way, the geometry of breakup became a phantom architecture, an imagined scaffolding built to explain absence. Astronomers could sketch the shapes, run the models, and speak of debris dispersal, but they could not point to proof. 3I. Atlas seemed to deny even the dignity of an observable aftermath, leaving only the suggestion of fragments fleeing invisibly into the dark. Around the world, observatories kept turning their mirrors skyward, even after predictions warned there was nothing left to see. Nights were scheduled, detectors cooled, exposures run, yet the results returned the same: frames filled with stars, noise, and emptiness. For those who had hoped to salvage the mystery, it was a bitter vigil, a network of quiet observatories pointing into void. The frustration was profound. Instruments that had once captured galaxies billions of light years away could not hold on to a visitor that had passed almost within reach. Data pipelines that measured exoplanet atmospheres and gravitational lenses now yielded only negatives, flat lines where signals should have been. It felt as if the universe had staged a disappearance act, daring the finest tools of science to follow and then mocking their limits. At conferences and in private communications, astronomers admitted a kind of grief. To prepare for months of observation, only to have the target collapse within days, was more than a scientific inconvenience. It was a reminder of how fragile the frontier truly is. No matter how powerful the telescope, it cannot compel the universe to reveal what it withholds. Still, the silence of observatories had value. Non-detections are data too. Each empty frame confirmed that Atlas had faded beyond thresholds. Each null result constrained models, tightening estimates of its mass, its fragmentation, its dust dispersal. Even in loss, the absence etched faint outlines of what must have happened. For the broader public, however, the quiet was invisible. News outlets had moved on, and NASA no longer issued statements. The global scientific network, working in silence, appeared complicit in mystery. To those outside, the lack of words suggested secrecy. To those inside, it was resignation, a recognition that the comet was gone, and only patience remained until the next chance arrived. Thus, the world's observatories, once aligned in urgent pursuit, ended in shared stillness. Telescopes scanned the heavens, but their quarry had slipped away. And so, science recorded its defeat not with revelation, but with silence. Within NASA, the vanishing of 3I, Atlas, created a quiet dilemma. The agency had celebrated the discovery of a third interstellar visitor, anticipating public excitement and scientific returns. Proposals had been lined up for Hubble, for spectroscopy, for collaborative campaigns across observatories. Funding had been allocated, schedules rearranged. Then, before the machinery of research could properly begin, the object dissolved. How should an institution respond to mystery undone by absence? To admit that a comet had simply vanished felt anticlimactic, almost embarrassing. Agencies thrive on deliverables, data, images, results that can be archived and publicized. Atlas offered none of these. To announce its disappearance was to announce failure, not of scientists but of circumstance. The bureaucratic reflex was silence. Reports were filed internally, catalogues updated, but press releases ceased. To communicate uncertainty is to risk misinterpretation, to risk speculation running ahead of fact. Better, some argued, to let the story fade than to feed narratives of conspiracy or incompetence. Yet in withholding words, NASA inadvertently amplified suspicion. Absence of explanation is easily mistaken for concealment. Behind the scenes, the dilemma was pragmatic. Telescope time is precious. Resources must be allocated to objects that can yield results. Pursuing a vanished comet would mean diverting attention from active targets, galaxies, exoplanets, nearby asteroids that still shine. The machinery of science cannot linger on ghosts, no matter how tantalizing. Yet some within the community urged transparency. They argued that mystery is part of science, that absence is itself a discovery. To lose 3I, Atlas was not failure but data, a reminder that the cosmos offers only fragments, and that sometimes the fragment is absence itself. The agency never reached consensus. Instead, the story dwindled. A press silence stood in place of closure, leaving room for conspiracy theories, philosophical musings, and speculation untethered from fact. The NASA dilemma became emblematic of the larger theme. When the universe refuses to explain itself, institutions must choose whether to admit uncertainty or retreat into quiet. For the scientific community, the disappearance of 3I, Atlas, was a reminder of an uncomfortable truth. Sometimes science falters, not for lack of rigor, but for lack of evidence. The methods were sound, the instruments ready, the models prepared. Yet the cosmos provided no material to test them against. In such moments, science does not fail in principle, but in practice silenced by the absence of data. This faltering carried weight. Astronomy is a discipline built on patience, on waiting years for orbits to return, for light from distant galaxies to arrive. But even within that culture of endurance, there is an expectation of eventual clarity. With Atlas, there was none. Its story ended mid-sentence, leaving researchers with half-formed graphs, incomplete spectra, and probabilities spread too wide to be useful. Some scientists admitted frustration, even grief. Others found humility in the loss. To be reminded that not every question yields an answer is to confront the limits of human reach. In the face of disappearance, science must learn to let go, to acknowledge uncertainty not as weakness but as reality. This humility is not new. History is full of mysteries that resisted explanation for centuries. Pulsars mistaken for alien signals, dark matter inferred but unseen, gamma-ray bursts that defied origin stories. Each eventually yielded to persistence and better tools. Perhaps interstellar visitors will follow the same path, their riddles solved not today but tomorrow, when humanity's instruments sharpen again. Yet Atlas's vanishing was different in tone. It was not a puzzle awaiting a key, but a key that crumbled before it could turn. It left no enduring trace, no dataset to revisit, no archive to mine. It faltered not because science misunderstood, but because the universe withdrew the very evidence needed to understand. Thus, the episode became a parable. Science falters, yes, but faltering is not failure. It is a reminder that knowledge is conditional, contingent on what the cosmos chooses to reveal. And sometimes, the most important lesson is that even the greatest methods are powerless against silence. In earlier centuries, comets were not studied but feared. They were omens across the sky, fiery apparitions that broke the orderly dance of stars and planets. Chroniclers described them as harbingers of plague, war, or the death of kings. Their sudden arrivals and inexplicable departures filled the human imagination with dread. The vanishing of 3I, Atlas carried an eerie echo of those older times. Here, too, was a body that appeared without warning, stirred wonder and unease, and then disappeared into nothing. The difference was that now the world had telescopes and equations, not prophecies and superstition. Yet the emotional rhythm was the same: awe, confusion, silence. Historians recall comets like the one that blazed in 1066, immortalized in the Bayeux tapestry as an omen of conquest, or the comet of 1347, remembered alongside the Black Death. Such events etched fear into memory precisely because they were inexplicable. People looked up, saw change in the heavens, and interpreted it as a mirror of human fate. Atlas's fate did not summon dread of plague or kings' deaths, but it stirred a quieter resonance. Its abrupt disappearance felt uncanny, almost theatrical, as though the universe had staged a vanishing act. For some, this revived the ancient sense that celestial events are not merely mechanical but meaningful, carriers of hidden messages. Modern science insists otherwise. Comets are natural bodies, their appearances governed by physics, not fate. Yet the echo across centuries is undeniable. Human beings are pattern seekers, and when the sky breaks its pattern, whether in medieval Europe or in a 21st century observatory, the reaction is the same: unease, speculation, and the search for meaning. Thus, 3I, Atlas, linked the present to the past. Its disappearance was a scientific puzzle, yes, but it was also a cultural echo, a reminder that mystery in the heavens has always unsettled humanity. In its vanishing, one could hear not only the silence of modern telescopes, but also the whispers of medieval chroniclers, gazing upward in fear. When the object slipped from science into silence, another kind of storytelling rose to fill the void: myth reborn. Just as comets once inspired tales of wrathful gods and prophetic omens, the vanishing of 3I, Atlas invited cultural narratives that lay beyond mathematics. On social platforms, people spoke of it not as a comet but as a messenger, an envoy that arrived, lingered briefly, and departed before its meaning could be grasped. Memes cast it as a cosmic visitor, sent to remind humanity of its smallness. Conspiracy circles wove it into elaborate dramas of hidden knowledge. suggesting alien design or governmental secrecy. Poets and essayists, meanwhile, wrote of its fragility as metaphor, a star-born wanderer dissolving under the gaze of the sun, mirroring the fleeting nature of human lives. The absence of data gave myth freedom. Without images to anchor imagination, the object became whatever narrative was needed. For some, it was a warning about planetary fragility, the reminder that our own world could vanish just as suddenly. For others, it symbolized resilience undone, the irony of a body that had crossed galaxies only to dissolve within sight of Earth. This remythologizing was not new but ancient. Humans have always filled the gaps in the heavens with story. What changed was the context. Telescopes and satellites now stand alongside imagination, yet both respond to the same silence. The disappearance of 3I, Atlas, was a scientific event, but its cultural afterlife resembled the comet fears of medieval Europe. Mystery does not vanish with technology, it simply changes shape. Thus, 3I, Atlas, lived on not in data, but in metaphor. It became a parable of impermanence, a reminder that even in the age of spectroscopy and orbital mechanics, the cosmos still speaks in riddles. Where science could not finish the sentence, myth took over, proving once more that humanity cannot look into a dark sky without inventing meaning. Among the most speculative voices was a suggestion rooted not in myth, but in the strangeness of quantum mechanics, that 3I, Atlas, had been undone by a kind of quantum fog. In this view, its fragility was not merely physical, but probabilistic, as if the bonds holding it together were balanced on the edge of coherence. Quantum decoherence governs the transition from possibility to solidity. On atomic scales, particles exist in clouds of probability, their states only fixed when observed or when interactions collapse their wave functions. For everyday matter, the effect is negligible. Our world is stable because probabilities average into certainty. But some theorists dared to imagine that an object assembled under alien conditions might embody unusual instabilities, magnified by eons in interstellar dark. Perhaps, they mused, 3I, Atlas was a body whose cohesion depended on balances too delicate to survive starlight. Cosmic radiation, vacuum chemistry, and quantum tunneling may have weakened its ices into metastable states, stable in the cold, dark, unstable once warmed. In this picture, the comet did not break. It decohered, its matter slipping from solidity into dispersal, a snowdrift of probability dissolving into photons. Mainstream astronomers found little reason to invoke such ideas. The known physics of sublimation and tidal stress explained enough, yet the language of quantum fog carried symbolic weight. It captured the sense that Atlas was never solid in the way we expect, that it belonged as much to uncertainty as to matter. In cultural retellings, this idea gained traction not as science, but as poetry. The comet became an allegory for human existence, stable only briefly, dissolving under scrutiny, real and unreal at once. It mirrored the way lives seem to vanish into memory, how certainty itself feels fragile. Thus, even in speculation, Atlas reminded humanity of its place. Whether undone by heat, gravity, or quantum fog, its disappearance echoed the truth that the universe is woven of uncertainty and that sometimes the fog does not clear. Another speculation turned the gaze from the quantum to the gravitational, imagining phantom wells hidden in the fabric of space. Gravity, the most familiar of forces, is also the most elusive, revealing itself only through motion. If 3I, Atlas, had vanished more abruptly than expected, could it have brushed against an unseen well, a pocket of curvature, a mass that revealed itself only by distortion? The solar system's chart is thought to be complete at large scales. Every planet, every moon, every major asteroid has been tracked with precision. Yet smaller bodies, rogue masses, even primordial black holes the size of mountains remain possible in theory. If such an invisible object lay near the path of Atlas, its pull might have sheared the fragile body apart, scattering fragments into invisibility. Some astrophysicists entertained the thought cautiously. Could the disintegration be a chance encounter with an undetected mass in the outer system? A fragment of dark matter, clumped unusually dense? A relic planetesimal orbiting invisibly in resonance? Most dismissed these possibilities as unlikely, yet they admitted the allure. Gravity remains the oldest riddle, and even a vanished comet could become its test. Others took the idea further, imagining phantom wells not as masses but as perturbations in space-time itself. The solar system, after all, moves through the galaxy, threading through spiral arms and dark matter halos. Perhaps 3I, Atlas had wandered into a subtle gradient, a pocket of curvature invisible to us but fatal to it. No evidence confirmed such ghosts. The hypothesis, like many, was built more on absence than proof, yet it served a symbolic purpose. The notion of phantom wells reminded humanity that the map of gravity is never finished, that unseen forces may lurk even within a system we believe we know. And so, in the silence left by Atlas, scientists considered that its disappearance might not only reflect fragility, but also hint, however faintly, at the hidden masses shaping a cosmos still incompletely drawn. If fragments of 3I, Atlas did survive, they were lost to invisibility, drifting back into infinity. The models suggested that whatever remained pebbles, dust, perhaps a shard of nucleus, would escape the solar system on a hyperbolic course, never to return. Within decades, they would be farther than Pluto. Within centuries, farther than the outermost Oort cloud. Within millennia, indistinguishable from the background of interstellar space. This fate was humbling. Humanity had been granted a rare visitor, a traveler that had crossed light years to brush past our star, only to slip away again with nothing to show but unanswered questions. The Earth had held it in view for a heartbeat of cosmic time, then lost it forever. Unlike planets, which circle reliably, or comets, which return in centuries, this object belonged to no cycle. Its path was a one-way exit, carrying it back into the galactic dark. There is a melancholy in such departures. To gaze upon something fleeting is to confront impermanence. 3I, Atlas embodied that truth at a cosmic scale. It was not destroyed entirely, rather, it dispersed into dust too faint to see, fragments too distant to follow. It existed still, but in ways that denied comprehension, scattered beyond reach, folded back into infinity. Astronomers noted the irony. Instruments had been ready, theories sharpened, anticipation high, yet the cosmos granted no closure. The fragments that could have revealed alien chemistry and stellar origins now drift in silence, their secrets carried away into the galactic void. And so, Atlas became a metaphor for the human condition itself. We glimpse, we yearn, we prepare, and still the universe withholds. The fragments remain, but not for us. They belong now to deep space once more, their faint trajectories tracing paths beyond observation. In the end, the comet did not end. It simply continued elsewhere, into realms we cannot follow, vanishing into the same infinity from which it came. The vanishing of 3I, Atlas did not close a door, it opened a resolve. Astronomers looked ahead, determined that the next interstellar visitor would not escape so easily. The Vera C. Rubin Observatory, with its sweeping legacy survey of space and time, stood at the center of this anticipation. Its 8.4-meter mirror and panoramic camera will capture the entire southern sky every few nights, charting faint wanderers before they slip into invisibility. Where Atlas was found late, Rubin will find early. The James Webb Space Telescope also carried promise. Positioned far from Earth's glare, with instruments sensitive to faint infrared signals, Webb could dissect the chemistry of interstellar debris with unprecedented clarity. Had 3I, Atlas, endured long enough, Webb might have revealed its molecular secrets. Though that chance was lost, astronomers know another visitor will come, and Webb waits, ready. Ground-based giants join the watch: the European Extremely Large Telescope, the 30-meter telescope, and other behemoths still under construction. With adaptive optics and massive light-gathering power, they could resolve fragments invisible to smaller scopes. Even radio arrays and radar facilities, designed for near-Earth asteroids, may be repurposed in the hunt, probing interstellar guests with new tools. Citizen science, too, will have a role. Networks of amateur telescopes, coordinated by software, could act as an early warning net, spotting faint streaks that surveys might miss. The lesson of 3I, Atlas, was not only about fragility, but about preparedness. To catch the next ghost, the world must look together, with every eye that can. In proposals and funding documents, its name has become shorthand. The Atlas problem, invoked to justify resources, to remind agencies that opportunities vanish quickly. Failure sharpened ambition. The loss has become momentum. And so, while 3I, Atlas, drifts into infinity, humanity builds its watchtowers higher. The next interstellar messenger will not be followed by silence. The cosmos will speak again, and this time, telescopes will be waiting. Beyond telescopes and equations, the mystery of 3I, Atlas, touched something more intimate: a mirror to ourselves. Why did its disappearance disturb us so deeply? Why did a faint smudge of dust, glimpsed only briefly, spark suspicion, wonder, and grief? The answer lies less in physics than in psychology. Humans fear the fleeting. We live in a world where permanence is illusion, where lives end, civilizations fade, memories dissolve. Yet we long for continuity, for things that last. The cosmos seems to promise that permanent stars that burn for billions of years, galaxies that span eternity. When something arrives from the galactic dark only to vanish within weeks, it shatters that illusion. The fleeting quality of 3I, Atlas, reminded us too much of ourselves. Its story felt like allegory, a traveler crossing infinite distances, carrying the weight of ancient origins, only to collapse at the threshold of revelation. How different is that from the human condition? We journey, we endure, we hope to leave a mark, and yet so much of our existence dissolves into silence before it can be recorded. This is why conspiracy theories flourished, why myths reawakened, why scientists debated so fiercely. The object was more than data. It was a stage onto which humanity projected its anxieties. To some, it was proof of fragility. To others, a symbol of secrecy. To many, it was simply a reminder that the universe does not promise clarity, only glimpses. In its vanishing, 3I, Atlas, held up a mirror. It showed us our hunger for meaning, our discomfort with silence, our tendency to invent stories where evidence fails. It revealed that what we fear most is not the unknown, but the unknowable, the possibility that some mysteries will remain forever beyond our reach. And so, the comet became less an object than an experience, a fleeting reflection of humanity itself. In the silence left behind, some turned not to data, but to philosophy. The vanishing of 3I, Atlas, suggested a disruption not only of cometary science, but of time itself. If something can arrive across eons, endure interstellar gulfs, and then collapse within a breath of observation, what does that say about the arrow of time we take for granted? Physicists describe time as one-directional, guided by entropy. Systems evolve from order into disorder, from coherence into fragmentation. 3I, Atlas, seemed to embody this principle perfectly, dissolving into dust. Yet its suddenness felt unnatural. as though the arrow had bent, skipping steps. One moment, a comet, the next, only haze. It was less a gradual decay than a jump cut in the universe's film. Philosophers seized on this. They asked, is time truly continuous? Or do events like this reveal its discreteness, its stutter? Could the cosmos edit itself, erasing objects as though they had never been? The thought bordered on absurdity, yet it carried weight, because the disappearance had denied science the comfort of continuity. Others interpreted the event as allegory. Time does not care for our preparations. It does not promise revelation, it only flows. 3I, Atlas, arriving and vanishing, mirrored the brevity of human existence. Each life, too, is a traveler across gulfs of time, undone in an instant, leaving questions unanswered. Even in science, echoes of this thought surfaced. Some researchers noted how fragile our observations are, how much depends on fleeting opportunities. A comet's path aligns with our instruments only briefly. A fragment of time lost cannot be regained. The arrow of time bends not because physics fails, but because our perception is finite. Thus, 3I, Atlas became a parable of temporality. It was not only a comet that dissolved, but a reminder that time itself is merciless. Its arrow points forward, indifferent, leaving behind nothing but traces and the haunting suspicion that what is lost forever. As the data thinned and then vanished, a strange realization spread among astronomers. Absence itself had become the evidence. What they held in their hands was not a catalogue of fragments or spectra, but a record of silence. The non-detections, the empty frames, the null results, these became the legacy of 3I, Atlas. It is rare for science to build conclusions on what is not there. Yet with this object, the lack of signal was the signal. The collapse of brightness, the failure to recover fragments, the void where a nucleus should have been, each spoke louder than light. Atlas had left behind not a trail, but a hole. This inversion unsettled the culture of astronomy. Telescopes are meant to capture presence, to collect photons traveling across unimaginable distances. Their triumph is in what they reveal. To elevate absence to the status of data felt like surrender, and yet, surrender was all that was possible. The silence had weight. Philosophically, this touched a deeper chord. Humans are uneasy with nothingness. We crave substance, resolution, permanence. When confronted with disappearance, we invent explanations, conspiracies, myths. But 3I, Atlas, forced scientists to admit that sometimes the absence is the truth. The cosmos does not owe us visibility. Even in silence, patterns emerged. The rate of fading constrained the size of possible fragments. The total disappearance limited estimates of surviving mass. Absence became geometry, defined by what was no longer seen. Researchers learned to draw boundaries around the void, to make the nothingness speak. In the end, the wound of silence was also its legacy. 3I, Atlas did not reveal itself through presence, but through disappearance. It left behind a lesson as unsettling as it was profound, that sometimes the universe teaches not by showing but by withholding. Its vanishing was not a gap in science, but an austere form of knowledge, the knowledge of what cannot be grasped. The enigma of 3I, Atlas, revealed more than the fragility of a comet. It illuminated the unfinished state of our models of the cosmos. Astronomy often feels complete, its equations describing orbits with precision, its theories mapping the fates of stars and galaxies. But when an interstellar object arrives and collapses outside the bounds of prediction, the incompleteness is laid bare. In its vanishing, Atlas echoed other mysteries. Dark matter inferred, but unseen. Dark energy, driving expansion without explanation. Quantum fields humming beneath reality. yet resisting unification with gravity. Each is a reminder that science is not a closed book, but an open draft, with margins filled by question marks. Atlas joined their ranks, a fleeting footnote that pointed toward gaps we did not know were there. The failure to explain its disappearance cleanly did not undermine science, but exposed its frontier. Fragile aggregates, unseen populations, hidden gravitational influences, all are possibilities unaccounted for in the neatness of current models. If the universe is a puzzle, Atlas showed us a missing piece, one that dissolved before it could be fitted. For humanity, this incompleteness carries both frustration and wonder. Frustration because we crave closure, finality, certainty. Wonder because it means the cosmos is not finished, that mystery still saturates the night sky. To live in an incomplete universe is to live in one that remains alive, dynamic, surprising. Thus, the loss of Atlas became a mirror for the scientific project itself. We build models to hold the universe, and the universe slips through their fingers. We predict permanence and impermanence answers. We long for certainty, and mystery persists. The story of 3I, Atlas, is not the story of a failure. It is the story of a cosmos that refuses completion. An unfinished universe, vast and unyielding, still writing itself in silence and absence. At last, what remained was not a comet, but a mood, a soft fade into night. The scientific debates quieted, the news cycle moved on, and telescopes turned toward other skies. Yet the memory of 3I, Atlas, lingered, not as data points or spectra, but as an unresolved chord in the human imagination. Its story ended without ending. A visitor appeared, fragile and fleeting, then slipped away before its secrets could be spoken. In its vanishing, it offered a lesson no less profound than discovery, that the cosmos is not obliged to satisfy curiosity, that some mysteries dissolve before they can be named. The reflection this left was deeply human. We too are temporary travelers, moving across gulfs of time, seeking to leave meaning before we fade. In the brevity of 3I, Atlas, people saw themselves, a fragile structure enduring for a while, undone in an instant, leaving only memory and silence behind. And so the narrative softened. Astronomers prepared for the next visitor, institutions sharpened their instruments, poets turned disappearance into metaphor. The comet became not a failure but a reminder that absence is part of truth, that impermanence is woven into the universe as deeply as light. In the end, Atlas did not burn brightly or linger long. It whispered across the sky, dissolved, and left us staring into coordinates empty but resonant. A faint trail of questions, a hush where answers should have been. This was its gift. Not revelation, but humility. And as the night folded over the memory, the mystery settled into stillness. The universe had spoken, not in presence, but in absence. And in that silence, humanity was left to dream. And now, as the last echo of the vanished traveler fades, let the pacing slow. The comet is gone, the telescopes dim, and the numbers return to their quiet shelves. What lingers is a hush, a pause, the awareness of something that brushed against our knowing and slipped away again. Breathe and let that image soften, a fragment of another star system, wandering for millions of years, appearing for only weeks, dissolving into nothingness under the breath of our Sunday. It was never ours to keep. It was always a passing guest, a shadow of deep time. The mystery it left behind is not a wound, but a gift. It reminds us that the universe is not a machine built to serve our questions, but a vast and living silence, offering glimpses when it chooses, and perhaps it is better this way. If every secret unfolded on demand, wonder itself would grow thin. So let the story drift now, like dust in starlight. Imagine the fragments of Atlas scattered across infinity, invisible, unreachable, continuing their voyage through the dark. Somewhere, in some distant future, another world may glimpse them briefly, may wonder as we do. The cosmos is endless, and its mysteries are never truly lost, only passed along. Let your thoughts quiet with that vision, a night sky wide and calm, stars steady, the faint memory of a traveler that came, dissolved, and left us humbled. Rest in the knowledge that mystery is part of existence, that not everything must be solved, that sometimes it is enough to witness. The universe exhales, the silence deepens, the comet is gone, and in its absence we dream. Sweet dreams.